Okay, what if I told you that you're hallucinating right now? And no, that's not just some philosophical thought experiment. It's actually a leading theory in neuroscience, and it might just change how you see, well, everything. Think about it. What if the world you experience, in all its vivid, rich detail, isn't a direct window into what's actually out there? What if it's just a constant, active prediction, a story your brain tells itself that just so happens to be incredibly useful for keeping you alive? To really get our heads around this, we have to start with a fascinating and maybe slightly unsettling term from neuroscientist Anil Seth. He calls our everyday perception a controlled hallucination. So the theory is pretty simple at its core. Your brain is a prediction machine. It's constantly guessing what's causing all the information it's getting from your senses. And your perception, that is the guess. But it's not some wild fantasy, right? That's why it's controlled, because real-world sensory data is constantly updating and correcting the guess, keeping it tethered to reality. Now, here's where it gets really interesting. Take the dream machine experiment. Everyone gets the exact same input, the same flickering light, the same music, but the experiences people have are wildly different. Some see geometric patterns, others see entire landscapes or complex scenes. So you have to wonder, if perception was just a passive recording of the outside world, shouldn't we all see the same thing? This is a huge clue that the real action is happening inside our heads. So, okay, if our perception isn't just a recording of the world, what is it? Well, this leads us to the front-runner theory in neuroscience today, the brain as a prediction engine. This is the key framework. Instead of passively waiting for sights and sounds to come in and then figuring out what they are, your brain is actively predicting what it expects to see and hear at every single moment. It's always one step ahead. And I love this analogy because it really gets at how efficient this whole system is. Your brain, like a good detective, already has a working theory of the crime scene. That's its prediction. It doesn't waste energy reanalyzing every single detail that confirms the theory. It just focuses on the anomalies, the clues that don't fit. Those are the errors that force it to update its hypothesis. Okay, let's look at the mechanics of this. How does this prediction machine actually work? The algorithm behind it is called predictive coding, and it has this beautifully simple logic to it. The crucial thing to understand is that the brain is organized into a hierarchy. You've got higher, more abstract levels of the cortex constantly trying to predict what the lower, more sensory-focused levels are doing. This diagram shows a super simplified model. Imagine you have prediction units at a higher level sending a guess downwards. Then, at the lower level, error units compare that guess to the actual sensory input coming in. The only information that needs to be sent back up is the difference, the prediction error. Now you can see how this scales up. This basic pattern is repeated all the way up the brain's command chain. A high-level prediction, like I'm looking at a cat, cascades down into tons of little, low-level predictions about edges, textures, and shapes. And only the parts of the sensory signal that violate those predictions, the surprises, get sent back up the chain. It's an incredibly efficient way to process the world because the brain only deals with what's new or unexpected. But this whole thing isn't just about passively seeing the world. The same principle applies to how we act within it. This is where we get into a theory called active inference. This is such a powerful twist. If your brain doesn't like prediction errors, it has two ways to fix them. It can update its predictions to better match the world, that's perception, or it can act on the world to make the world match its predictions. So, if your brain predicts you're drinking coffee, you will actually act to bring that cup to your lips and make the prediction come true. Ultimately, the brain is always trying to minimize surprise, or what neuroscientists call free energy. When it comes to perception, it's about having an accurate model of the world without it being overly complicated. For action, it's a bit of a trade-off. Imagine you're exploring a new city. You have to balance the reward of finding a great restaurant with the need to gather information, like looking at a map, to reduce the uncertainty of getting lost. Okay, so this all sounds like a really powerful explanation for the mechanics of the brain. But does it explain the biggest mystery of all? Consciousness itself. You know, that subjective, qualitative feeling of what it's like to be you. And this is a really profound challenge. You can describe all the neural firings, the prediction errors, the free energy calculations you want. But how does that objective, mechanical stuff produce the subjective experience of seeing the color red or feeling happy? It seems like there's this huge explanatory gap that a purely mechanical story just can't cross. On the other hand, the alternative view, that maybe consciousness is fundamental, that has its challenges too. As this comment rightly points out, just saying it's all in the mind is kind of an intellectual shortcut. It doesn't really explain the detailed and predictable nature of our reality. It doesn't tell us why we experience things the way we do, or why physical laws seem so consistent. It kind of feels like you're just trading one mystery for another. So, we're left with this final, really mind-bending thought. If the world you experience is a controlled hallucination generated by your brain's predictions, then what about the self? Is the you at the center of that experience also just another one of the brain's best guesses?